Assalamualaikum. We are from Group 3, numerical method BEE 32402 section 2. We will present our group project. This group contains 3 members. First is Muhammad Israf Izzuddin bin Abdul Rahman. Second, Muhammad Izam bin Muhtazah. And the last one, myself, Muhammad Naim Shazim bin Nur Azam. I will present the introduction of this project. Lagrange interpolation is a numerical method for evaluating a function from a series of data points. This approach is developed by Joseph Louis Lagrange. It creates polynomial of the least degree that goes across the data point supplied. The interpolation polynomial is defined as a sum of Lagrange basic polynomial. The resultant polynomial is closely similar with the original data. Lagrange interpolation is useful tools in numerical analysis. It can make approximation value for a curve fitting and other applications requiring an accurate representation of a function. This is data that we collect from internet from the original engineering source. So this data is about renewable of wind energy in ASEAN. This data actually have a hydropower, solar, wind and other energy source. But we choose only to make experiment of the wind data, and we filter the location to the ASEAN only. So at the right is a table that we collect, a table that generate from the data that we want, which is ASEAN for wind energy. Okay, we move to the calculation. I will explain about Lagrange interpolation method. This method have 3 ways to find the approximation. First, we use linear approximation. We want to find a renewable energy from wind in years 2017. So we draw a table, use 2016 and 2018. It is because 2017 is in the middle between 2016 and 2018. So X is years and Y is a value that we want to find, which is renewable energy from wind. So we use formula X minus B divide by A minus B multiplied by Y. X is the year that we want to find, which is 2017. B, A is first year and B is second year, which is 2016 and 2018. We just enter the value to the formula. So we get 2.5 for renewable energy from wind in years 2017. So we report to the table. The approximation value is same with original value from the original data. Next, we use quadratic approximation. The formula is similar with the linear approximation. So we just add 2015 in the table, which is 1 year before 2016. This formula is X minus B multiplied by X minus C divided by A minus B multiplied by A minus C and multiplied by Y. So we just enter the formula and we get 2.2667. So the formula is not same, but is little bit approach to the original data. Last is cubic approximation. In this formula, we just add 2014 in the table, and the formula is similar with quadratic approximation, but we just add for 2014. So we just enter the value to the formula and we get 2.035. So we know the answer from cubic approximation is more far from quadratic approximation.
Assalamualaikum warahmatullahi wabarakatuh. wabarakatuh. My name is Muhammad Izam bin Muhtaza. My metric number is CE220088. I handle about Newton divide different method. So firstly is the data represent the relationship between two variable x and y over the years 2013, 14, 15 and 16 and 18. The value of x, the value of y determined or as f bracket x show an increasing trend over time. In 2013, y is 0.45 and it steadily rises to 3.47 in 2018. This suggests a positive correlation between the variable, indicating that as the value of x increase, the corresponding value of y also increase. The progression highlight a potential pattern or trend that could be further explored and analyzed for insight or prediction. Okay. Let's go to calculation. The first calculation we use we must find Fi naught. For Fi naught 0.53 minus 0.45 divide 2014 minus 2013 and we get 0.08. And next for 0.73 1.26 divide minus 0.53 divided 2015 minus 2014 and we get 0.73, and so on. We use same method. Next is secondly we find Fi square. How we get 0.325 is we use this formula, 0.73 minus 0.08 divided to 2015 minus 2013 and we get 0.325. And next is 0.27 minus 0.73 over 2016 minus 2014 and we get negative 0.23, and so on. We get 0.233. For Fi power of 3 I use minus 0.23 minus 0.325 divided 2016 minus 2013 and you get negative 0.185. Is a error, please. And next for 0.1158 same, we use 0.233 minus negative 0.23 and we get positive over 2018 minus 2014 and we get 0.1158. So Fi the power of 4 we use at this Fi power of 3 0.1158 minus negative 0.185 divide with 2018 with 2013 and we get 0.0602. But the last value for Fx is 0.45 plus 0.32 plus 3.9 minus 4.44 plus 0.4448 and we get the last answer for Fx is 1.6708. That's a last answer for find Fx using Newton divide different method. Thank you.
Assalamualaikum. My name is Muhammad Ishaq Iruddin bin Abdul Rahman. So today I will explain for simulations MATLAB. So for linear approximations, so this is the coding. All we have to do is to declare, and then when we already declare all the information, so we have to run. When we answer, or the answer will be 2.5. So 2.5 means that we prove that our calculation is correct. So next is quadratic approximations. Okay, it's the same as linear. So we have to do is 1. So the answer is 2.2667. Same with the calculations. So it means it proves that our calculation is correct. Next is linear. Next is cubics. So same thing. Or the difference between all these is this one. So it's linear. So it's SP line and so also SP lines. So next is cubic approximations. So when we run, okay, the answer is 2.035. Same with the applications. Okay, next and last, for Newton divided difference. So this is all the coding we have to use. We have to key in the information. So when we run, it gives the tables, the answer for tables, and the interpolated value at x for 2017 is 1.67. And then last, for conclusions, wind energy research, along with mathematical techniques such as Lagrange interpolation and Newton divided difference, exemplifies the joint effort in sustainable technology. Wind energy, a sustainable alternative to fossil fuel, illustrates human capacity to strategically harness nature force. Lagrange interpolation is a basic yet efficient method for estimating function, but it should be used with caution, due to possible oscillations. Newton divided difference, named after Isaac Newton, adds numerical complexity and is useful in exact approximations. These components, when combined, leads to more sustainable and efficient global energy landscape.